So what we have to do in Postgres is this. We have to, everybody go to your command line and you type create DB, what are we going to call this database?
Students.
Yeah, the table's students. We can call the database the same name as the table. Let's call it something else. Let's call it school. School DB. Oh, I already have a school DB. All right, I'm going to call mine school. You call yours school DB, I'll call mine school DB too. All right? Create data. I'm recording this, Courtney, just so you know you can go back and.
And this is specific to
Postgres, yep. Create DB is a command for Postgres, and the name of the database is SchoolDB. Yours says command not found? Okay, can I pause the recording?
Surely you can.
Who else got command not found? Anybody else? All right. Should be able to run it from anywhere. Type which space create DB. Oh, he wasn't here for the, okay. All right. So now we can run this command. What we're going to do is next thing you got to do, everybody, PSQL, that drops you into the Postgres. I hope you haven't done it yet because I haven't done it yet. PSQL, school, you're going to write school DB, I'm going to write school DB too. And you should get this prompt here that says, yours will say school DB hash, mine says school DB too. Who had any trouble with that? Everybody good? PSQL, you guys type PSQL school DB, and you should have school DB prompt here. This is the Postgres command interpreter. Remember when we went into Mongo and we did show DBs? This is the equivalent for Postgres. All right? And PSQL is probably Postgres SQL interpreter, blah, blah, blah. So let's do this. Let's do a /D to describe the table. There's nothing there yet. You do a /D, there's nothing there yet, right? Okay, \D. And the way we leave the interpreter is we do \Q and we quit and we're out. Do a \Q. We're out. And then I'm just going to up arrow again to go back in. I'm going to up arrow to PSQ, school DB, and I'm back into the thing. So everybody get back in by running the PSQL school DB again. Am I waiting for anybody? Courtney, you there? Cool. You good, Shazad, or no? Okay, all right. So we are going, let me do it first. I'm doing this off script. I'm going to copy this thing and I'm going to run it and see what happens. Okay, yeah, you got it. All y'all just click this copy here, click copy, paste it into your PSQ thing, and hit enter. And then do a \D, and you should see, when you do a \C, you should see that there's two things in there now. Anybody not get that? Okay. No. Sure. This is from the lecture.
No, do \D.
From the lecture.
Oh.
With that one last command, I should get two.
Yes.
Those tables, I got a schema, but I didn't get a second. I think you have the same thing that I. Or rather, I mean, I guess I got one. Oh, okay.
We did it twice.
We're waiting on Shazad. Let us know when you're ready.
Oh, we're right here.
You're right here now? Okay, so what happened was it created two things for you. It created your student table and also created this ID sequencer. And it's going to use that to create the primary key. You don't need to know too much about that yet.
Sorry, weird question. The owner name,
Mhm.
is that my Apple name?
That's the name. That's the name that your computer. When you log into your computer, that's the name your computer knows you as.
So you would use the users if like the company or Tori already like made something and like the users are whoever
Are you listening?
the users are whoever is working on that table, and so you can adjust the access that your employees have to the database, and that's where you
Mhm.
use that. So you install yourself and you don't have to worry about that yet.
Yep. And there's a whole big part of this lecture about users and roles that I'm going to say we're not going to deal with, because for junior developers, what you need to know is on your system, when you do something, you are going to be the owner of it, and you are going to have access to it. All right, and that's all you need right now for junior developers. You can read that lecture part about roles and who can access what. I think it's overkill for what you need to know right now at this point in your career. Okay? Okay. But you can, like Devin said, you can restrict who's allowed to access things by setting the owner and their rights and stuff like that. Okay, so what the point I wanted to make here was, if we do a slash, watch up here first, a /D on students, and it'll do, hit tab, it'll complete it for you. Here's what we did. Go everybody do a /D space students. All right. This command here, /D students, and you should see the table that you just created with all of its rows and everything. Did anybody not get this? Sarah, did you get it? Okay, just to look. I thought you were. Okay, so here are some commands. This is what you did, but when you do it, just look up here. When I did a /D, it said it created a table and a sequence. And the sequence is what it's going to use under the covers to generate your primary keys. Okay? It's not going to go look at your student table to see what the biggest one is and add one to it. No. Under the covers, it's going to keep the next number to assign your primary key in a separate table. That's all you need to know about that. MySQL doesn't do this. I don't know how MySQL does it.
How come it pulled up some of the commands we put in, but like on email, there's not a unique thing like it said in the table? But it will tell you.
You should. Primary key. Yeah, there it is. It's underneath. Students, email key, unique constraint. Boom. It's a little bit obfuscated.
Okay, so it's not, it just doesn't line up with the
Yeah.
modifiers. Got it.
Yeah, this is where it's telling you that it's set the unique constraint on it somewhere else. We don't need to know everything that's going on there at the moment. Good question. What you do glean out of this is that this is the ID. It's the primary key. It's going to use the sequencers to generate the thing. It's not null. Its default is use the sequencer. Name of it, character, varchar up to 100, email varchar up to 100, favorite, blah, 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 blah. All right, pretty much took that created the table, and when you say describe the table, it kind of looks like your create table statement, but in its own Postgres way. Now, if I do this in MySQL, you'll see that MySQL is different. Let me just show you, each database, every SQL database will take the SQL language, like the create table. I can do a create table in Postgres, I can do a create table in MySQL, and they all have their little quirks as to how you define primary key. And like, for example, see this serial in Postgres? In MySQL, you say auto increment. Okay, so each database has its own little unique stuff, but they all adhere to the SQL query languages, which is insert, update, delete, and select. Those 4 commands you can run against any database. They're common amongst every database, which is CRUD. Create is insert, retrieve is select, update is update, delete is delete. So those 4 things, you can write the same SQL and every database will work on it. What they're unique about is how you create a table. You know, the way you do things. So just take my word for that. All right, let's do this. Let's just do one of these lines, but before we do it, here, I'm gonna put this in my editor and we'll just talk about one of the lines. Whoa, I don't know what I just did there. Okay. Whoa, don't wanna see that. Okay. This is common to every database. Insert into students. This, you can run this against MySQL, Oracle, whatever. These insert statements are all done this way. Insert into whatever the table name, and you put parentheses, and you put the columns that you're going to insert into. All right, and then you put the word values, and you put parentheses again, and you put the values that you want to go into the column. So name is going to be Charlie. Favorite candy is going to be Skittles. Graduate is going to be T, whatever the heck that means. Cohort's going to be 1. Rinse, ladder, repeat. That's how you insert. You guys, this is how you insert. And if I could show you the SQL I wrote for Nike, it's hundreds of lines like this. Hundreds and hundreds of lines. I can show you the SQL I did for my poker database. Just hundreds of lines of this SQL stuff to insert, update, delete, to CRUD. So I'm gonna run one first, and then you can, let's make sure it works for me. So here we go. I'm going to run the insert. Oh, before I do, let's do a query to make sure nothing's there. I don't know if there's a faster way to get rid of this. The way you query, I'm going to do select star from student, is it table student?
Schools.
No, that's the database, the table students. Yeah. Okay, here, let me put this here. First, I'm going to do a query. Select everything from students. I'm going to run that first and there's nothing there. Then I'm going to run an insert statement and I'm going to rerun the select and we should see one thing. So first let me run the select and it says 0 rows. It returns back the column headings and it says 0 rows. You with me on that? Now I'm going to insert. I'm inserting and it said, hey, insert 0, 1, whatever that means. I assume that means. Now let me run my select again and there's the row I just did. You all do that. Do a select star from students. You should get 0. Do the first insert and then do select star from students again and you should have that one row. Yeah.
Instead of, Bailey and I said the same thing. It didn't come up with school DB equals hashtag. It said end, and now we can't do anything.
What did you do?
Oh, thank you.
What have
The
you
Q.
done?
Yeah, you got to get, there you go. Now you can do it. Select star from student. From students, I think it's plural, students. Do a slash, no. Huh, okay, now, no, that's right, select star from students. Oh, you gotta put a semicolon again. Boom, now do,
But I didn't do anything. I needed to write.
semi, whatever the one is. Hey, by the way, SQL is really picky about the way you end your things. You have to put, what's that called, a semicolon. You have to put a semicolon on the end. You have to put a semicolon. SQL is really, really picky that you end your stuff with a semicolon.
I got you. I got an error.
And then I did it on accident, right? Cool. No more forward,
So
no more
let's
slashes.
start from student to student.
So do I just fix it?
Oh, you got three different statements.
Oh, okay.
You see that? There's like a super subtle difference in the prompt if you leave a semicolon on. See how it says school equals pound? If you don't put a semicolon there, it changes to school dash pound. So it's a difference between a dash and an equal sign, and the prompt tells you if it's still expecting more. That's almost even.
Oh.
Go ahead and enter all three. After you get one in there, enter the next two.
Alright, so here's what's gonna happen.
Oh, yeah.
Maybe you're not. It's,
Maybe.
is half
And Gil, the third one, we're able to add multiple value sets because they're all
like,
doing the same columns, is that right?
One moment.
it needs to know, because right now I think you're still like Python more stuff. She types line by line other stuff. You look at that syntax, it's from equal to.
Okay, what's that?
In the third example, we're able to include two value sets at once because it's using the same columns versus these, the favorite candy and email.
That
We're able to-
I've never seen that before. Let me see what it's doing.
Okay.
Yeah, it looks like you can do multiples that way. I've never seen that
As
before.
long as they're using all
The same columns, yeah. I've never seen that before.
We're gonna go over how to delete one because I accidentally added Charlie in there twice.
It's okay, so did I. Nope, it's okay. Sure. Delete from, type delete from students where ID equals, and give it one, either one or two. Enter.
Do I
Or
just-
semicolon. Now do up arrow. See a deleted one. Up arrow. There you go. Boom. So number one's gone.
Sweet.
Okay, I'm fine. These are my colors.
Let me see what's next. Okay. Anybody not have 4 entries? Raise your hand or whatever if you don't have 4 entries. Okay. Should I help, sir?
There's
What?
4.
There's 3 insertions for.
Can you check on Sarah, please, she's up?
Yes.
You got 4 entries? 4 entries, 4 entries, 4 entries, 4 entries? 4 entries? 4 entries?
Yeah, I got 4. 4 little kids. Sure.
Okay. You can have, at least, as long as you got 4. It's good. All right, now, heads up, listen up. Listen up. Sarah said, oh, I did Charlie twice, so just watch, I'm gonna do Charlie twice, I'm gonna put Charlie in there again. And she said, oh, how do I get rid of one? So this is how you get rid, it's not part of the thing, I don't think, but this is how you get rid of one. Delete from students where ID equals what? I can get rid of 1 or 5. It doesn't matter. I'll get rid of 5.
This might be the most intuitive thing we've ever done.
All right.
It literally, you tell it what you want it to do, and it does exactly what you print.
Yeah, too bad we don't code with it because we're going to use an ORM instead, like Mongoose, and not do this. It's going to do it under the covers. Okay. Let's see what's next on the lecture. Create table, export. I don't care about exporting and importing at this time. Here, we're going to talk about where. We're going to talk about where. What time do we break for lunch?
1:30.
Okay. All right. For the moment, close your computers. I'm still recording, so you'll be able to get back to this. So remember, again, the Q in SQL is query. Where is what we use to query. All right, I think we did this in Mongoose or something, but where is how we query? You can do things like equals to, not equals to, greater than, is null, is not null, ands and ors, and then you can sort things and do stuff like that. So how about if we look at one here? We did this one already. Select star from student, right? Students, and we got all 4 back, right? I guess that I was premature. Why don't we do all these together? Sorry about this. Open up your computers and we'll do all these things, but we'll do them one at a time. Everybody do the first one, select star from students, and you should see at least 4 things. We've already done this multiple times. Let me know if I'm waiting for anybody to do select. Find this in the lecture. Find this part of the lecture and copy the first one. Select star from students and run it. And like I said, we've already done it multiple times. All right? And am I waiting for anybody? Which is cool because it takes time to find it in the lecture, cut and paste, run it in your thing. You good, Courtney? Or okay, now let's do the next one together. But this one we are telling it which columns we want. We're doing select name and favorite color. So on this one,
Favorite color does not exist.
Favorite candy.
such, yeah, see that? Let's make it favorite candy. There it goes. And you see how the result set, you'll hear the word result set over and over and over when you're talking about SQL. Result set is what comes back from the query. In this case, the result set just had the 2 columns that we called out. So why don't you all, just for the heck of it, add another column to that query. Just pick one, add ID, email or something and run it so you get 3 columns back. And remember, there has to be, all but the last one need a comma. You name the columns, they all have commas except for the last one, right before the word from. Check on Sarah, please. Really? Okay, you look wise. All right. So I'm gonna add the ID column because it's the shortest and I remember it. So I'm going to add comma ID, and now I have the ID in mind, right? So you can name the columns you want back. What's the next one? The next one is, we're doing a where clause. This is our first where clause. But I'm going to do a select star first. How many of them have T? Before, only one of them has graduated T. So when I run this next query.
In the query, change graduate to graduated.
Aha,
Yeah.
cool. So let's do that. Let's do graduated. Graduated. So I only get 1 back. There's only 1 with a T. So when I do where graduated equals T, I only get this 1 back. So, and now I think they say do where graduated equals F and you get the other 3 back. All right.
So this is very hypothetical. Well, it's not. I know it'll happen. So say we have a list table with 700 people in it. And their ID is created automatically. We're not giving it to them. Is there an easy way to go through and find the person you're looking for if you don't know the IDs?
With the where clause, you have to be uniquely narrow it down by whatever columns they have.
You know to be true for them.
Yeah.
Okay.
You could do like a select ID, comma, name from students where name equals Charlie.
Okay.
We're gonna do that.
And then would you want to pull like all of it? I mean, I guess it'd be smart to pull like the rest of the columns so you can figure out which one it is.
Yeah, you could, I mean,
Yeah.
yeah, you would specify whatever columns you want.
Yep. Okay. Let's do this is null thing here. Let's do select, I'm gonna leave this up. I'm gonna leave up the select star from, so who has, looks like 3 of them have a null email, right? So you all run this next one which says, select name from students where email is null. Go ahead and run that one, and you should get back the 3 which have a null email, because 3 of them don't have a value. So, somewhat intuitive. I mean, at least it reads like English. Select these things where this thing, I mean, it's not too bad. So let's, from what Sarah and Eric were just talking about, we're going to do one that's not in this. You can go through these other ones on your own. Let's see if there's anything interesting here. Yeah, let's do see how the height is a greater than equal to. How many are there?
Well, they don't have any height.
They don't have a height. Okay, whatever. How about where cohort is greater than 1? Let's do that one. Select name from students where cohort is greater than 1. And I got 3 back. Now let's do select name, comma, cohort. Name, comma, cohort. So if you run this query, select name, comma, cohort from students where whole cohort is greater than 1, you get all the ones that have a 12. You don't get the one that has a 1 because we said greater than 1. Okay? Let's do something a little more complicated. Let's do something with a little text thing here. How about, let me do a select star. How are we going to find Charlie? You two know. Anybody, what are we going to do for select just to get name Charlie? We don't know what the ID is. Yeah. I mean, we do because I'm showing, but if you didn't know what the ID is, yeah, we could do select star from
What if you added Charlie?
from students where ID equals 1. 1 second, let's just go with what Mahima said. Select star from students, let me just bring one. Select name cohort from students where ID equals 1. And we get Charlie, right? But let's say we don't know what the ID is. How can we, but we know somebody in there has a name Charlie. What can I do? Okay, let's do that. Select, let's do star. Select star from students where name equals Charlie. Boom, got one. It matched the name. All right, so that was select star from students where name equals Charlie. And I did it with single quotes because I've been doing this forever. I don't know if double quotes work. Let's find out. Nope, has to be single quotes. Has to be single quotes in SQL, not double quotes.
And if in Charlie you didn't spell it correctly, it would not work.
All right. Select star from student where name like.
Whoa.
What?
Oh, snap.
Oh, wait a minute, hold on. I got to make that a percentage. Oh! Like is where you use wildcard. All right.
So with that would be really helpful when you have something like Sarah and Sarah, where the
But
Sarahs
when
are
you can
spelled
do
differently.
this, if let's say you do this, let's say you do where name to lower, I don't know if I put parentheses on that now. This is how you do it in MySQL. I don't know how Postgres does it. No, I got to figure out how.
What if you like put in, if you're looking for Charlie, but you put in Charles, like is there a way to,
Yeah,
or like if
there's a way to do everything. You just got to Google it. I have to Google how to do two lower. Might as well go down here.
Two different things, but who knows how it's spelled?
Postgres, two lower example. Lower function. Oh, it's not two lower, it's lower. Lower. Give me an example. Show me an example, please. Email lower. Email lower email. Select first name email, comma, lower email. Okay, lower email. Let's try lower email. There it is. I got it. Now let me do this. There you go. This is how I did lowercase in Postgres. You say lower on the name equals Charlie, and it'll take Charlie, it'll turn it to lowercase, and then it'll compare it to that. That's how you do it in Postgres. All right, so you can do lowercase, uppercase.
So back to Sarah's question where like, what if her name is Charles? Can it do something where like,
Yes.
you say like, and you know
Yep.
that Charles and Charlie both share the common CHAR, right?
Is it or?
Could you just do
I'm doing
CH
it.
and then do, would you have to
Yep.
do that many,
Yep.
whatever it's called, sensitive signs, or?
All right, so this is one way you do it. You say, you do ors. You say name equals Charlie, or name equals Charles, or whatever. You can put a bunch of ors in there.
Okay.
But you could do a like on it as well. You can say like, if you know it all starts with Sarah or something,
Yeah.
you can do like and use a wildcard.
Okay, because it's gonna say if there's names like Anne that can be spelled different ways, like
Mm.
Bailey can be spelled different ways. But
You
if
can
you
do it.
know, okay,
You SQL, I don't want to go too far down this rabbit hole,
yeah,
but SQL is 30 years people have been using it. It's very powerful. You can set up these amazing where clauses, and you can narrow it down to what you want. But knowing how to set up these amazing where clauses is something you learn. We'll stick with the simple stuff, okay, for now. But yes, you can do that. All right, so back to the lecture.
are we gonna do
That's
this
it.
update one?
What? Oh.
Update.
Oh, hey, let's do an update. Everybody, run this update one. All right, so hey, what you got to know about update is this. It's probably spelled wrong again. Okay, hey, pay attention here for a second. What you do is you do a where clause to reduce it to what you want to update. And then over here you do set this equals that. But the where clause, if you don't do this where clause, it sets everything to yellow. If you don't have this where clause, everybody in there, I think it's Candy, right?
Candy,
Yes.
yes.
But if you don't have a where clause, it's going to update every row in the table. You have to have a where clause to reduce it to what a lot of times you do where ID equals this because you already know what the ID is. When you're doing CRUD and you're updating your to-do, you already know what the ID is. So in SQL, you'd say update done equals true where ID equals blah. All right. Normally these things are done where ID equals, but you can do any where clause you want. Does this one work?
No, because it's Candy.
It should be Candy. Favorite candy is yellow. Favorite candy
I love yellow.
equals
Skittles.
Skittles.
Taste the rainbow.
Skillets.
Skillets.
Yeah, it's going to be skillets. Nope. Wait a minute. I
Yeah,
didn't
because
copy it
Charlie
over.
didn't have candy.
You
Oh, I got to do
Oh.
favorite where favorite candy is null.
be nice if they gave us the.
Yeah, it would be, wouldn't it? Well, no, they weren't meant for this to be a thing. I just made this into an activity. They meant to be vague.
So if you changed both those back to color and entered it, would it create a column named
No.
color? No.
No.
Okay.
No way.
Can we inject colors, or would we have to make a new table?
You would have to alter your table. There's an alter table command to add a column to it.
Okay.
Yeah. Hey, that's a good question. That's another way that SQL differs from NoSQL. In NoSQL, you just throw new things on it, like favorite color. And when you're in Mongo, not when you're in Mongoose, because Mongoose restricts what you can do. But when you're in Mongo, you can just add properties out the wazoo just by adding them into your JSON. You can say favorite color is yellow. If it wasn't there before, you got favorite color. Doesn't happen in SQL. If it's not there, it'll say an error. Hey, you don't have a column of favorite color.
So you create a column.
Yeah, and you do that with an alter table command. You have to. It's another command that says alter table, add column, favorite color, blah blah blah. Ooh, no. Oh, very dangerous. Once you make, unless you have an audit trail set up, which is very graduate level stuff, in general, no. Once you make a change, it's gone forever. Which is also true for Mongo.
But you can still go back and re-update it with the
Yes,
information. If you know the previous
Yes.
information.
Yes.
And you could wrap it all in a transaction.
In SQL, you could wrap it in a transaction and but that's still, once you make the change, it's there. Okay, so let's see if there's anything else from lecture worth talking about. No, we're done with lecture. Now, lecture says you have this activity. We did way, way more than this activity. This activity says go out to SQL Fiddle and create a customer table. All right, we did way more than that. We created a database, we created a table, we inserted in the table, we selected from a table, we updated from a table. We did way more together than this activity wants you to do. It's optional. If you want to do this, you're welcome to do it. What we just did is 10 times more than what this is. Go ahead. I have no idea. No. That's why, I guess you can create table. I don't even know how to use it. I would suggest it's not worth the learning curve. What we just did in Postgres is real. And by the way, hey, what's going to happen now is today is basic SQL. Create a table, da-da-da-da-da. And what's more important is the daily project. Let's go look at the daily project, which has a kickoff later. But in the daily project, I think you do what we just did. You are going to create a to-do list with to-dos, okay? And then you're going to use this in the future, okay? So, and write a create table, write an insert. What we just did, you're going to do in Postgres, okay? So that's good that we just went through that. So this is what your daily project's going to be. Just do what we just did for students, but do it for a to-do list, okay? And you can go back. I'm still recording, so you can go back and look at my recording. And then later, when we get into the Mongoose for SQL, which is called SQLese or SQLize, we're going to be doing a lot of this. We're going to be going in and we're going to be going, hey, what is my database? What did it do? You know, we're going to be saying, show me the table. And we're going to be doing select star. And we're going to be in this SQL command line tool looking at what the ORM, what the Mongoose for SQL, which is called SQLese, does. So anyhow, just looking ahead. So today, here's your daily project. We'll have a kickoff after lunch. So let's say lunch is for the next hour, and then we'll have a kickoff for this thing. Okay? And I'm going to stop recording.